All right, so we are on lesson number 5 for this unit. It is about perpendicular lines, and your learning target is I can prove and apply theories about perpendicular lines. Okay, so let's get going here. Let's take a look at some things that we need to remember first. Okay, and we've got perpendicular bisector, and if we think back to that first lesson of this whole year, it says a line that splits another line segment at a something angle, and we know that perpendicular means that they're splitting at a 90-degree angle, right at the segment's midpoint. Okay, so a bisector splits the other line right at the midpoint. The shortest segment from a point to a line is perpendicular to the line. Perpendicular to the line. So what that's saying here is if we have some point and some line through here, the shortest distance from that point to that line has to be perpendicular. So if we think about this real quick, let's just talk about a little scenario here. If we're let's say we're at the park and we're playing in the grass area, and we're trying to get back to the sidewalk where our car is. Okay, the quickest way to get there would be to go from where you are straight to it, right? At a 90-degree angle. That would be the fastest way to get there. You wouldn't want to walk around the whole thing. You need to go from point A to point B. Now let's take a look at some of those theories behind perpendicular lines. And this first one, it says if two lines form a linear pair, and remember a linear pair is one that's adjacent meaning that their angles are right next to each other, and they're supplementary, which means they form 180 degrees. Okay. Of congruent angles, congruent being the same, then the lines will be perpendicular. So if two lines form a linear pair of congruent angles, then the lines will be perpendicular. And we know then that these congruent angles, they have to be 90-degree angles. Okay. The second theory says that in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well. So what we're taking a look at here is we've got two parallel lines. These are parallel. And if this line is transversal that cuts through those two lines, if one of these is perpendicular, if we know that this one's 90 degrees, then we know that this one has to be 90 degrees as well. That's just, it goes with it, okay? So now that leads into this third one. This third theory says if two coplanar lines are perpendicular, if they're perpendicular to the same line, then the two lines are parallel to each other. Okay, so if, same thing, this is just working backwards. If we have two coplanar lines, these ones right here, are perpendicular to that same line, so we have two 90-degree angles, then those two lines, these ones, have to be parallel to each other. There's no other way to explain it. Example 1 says, what is the shortest segment from point A to line BC? And then it says, write and solve an inequality for x given the diagram on the right. Okay, so let's first take a look at this first question. It says, what is the shortest segment from point A to line BC? And we know the shortest distance from A point to A line, this is BC here, the shortest distance is the one that is perpendicular to it. So that would be line AP is the shortest distance. And that's because, again, line AP is perpendicular to line BC. All right, now the second part of that question says, write and solve an inequality for x given the diagram on the right. Okay, so we're trying to figure out what x is. And here's what we do know. We do know that AP is going to be shorter than AC, correct? And we're writing an inequality, so we know that AC has to be greater than AP, because AP is the shortest distance to BC. All right. So now we're going to solve for what given values of x would make this a true statement. So let's go ahead and plug in. AC is x minus 8. We're going to plug in x minus 8 is greater than AP is 12. And now it's just solving that inequality. All we have to do is solve for x, add 8 to both sides, and we end up getting x is greater than 20. X cannot be anything less than 20, or else that's not going to be a true statement, because we know that AP is the shortest distance away from line BC. Alright, example 2 says that we need to write a 2-column proof given that R is parallel to S and angle 1 is congruent to angle 2. And our whole goal is to prove that line R is perpendicular to line T. So we want to prove this. We don't know it yet, but we want to prove that. Okay, so the first step, this is a 2-column proof. 2-column proof is where you have one side is statements, one side is reasons. Okay, so we're gonna start with some statements here. The first statement we're gonna provide is that R is parallel to S, and angle 1 is congruent to angle 2. Okay, and in the reasons part of that, we're going to give the reason why we can say that. And the reason why we can say that is that was just given to us. That in the problem, it tells us that this is the case. It says R is parallel to S, angle 1 is congruent to angle 2. Okay, so that's what we know to begin with. Now we have to kind of connect things. We have to connect how is 1 and 3 in order to make those two congruent, those have to be, in order to make lines R and T perpendicular, 1 and 3 have to be congruent, right? So we have to connect what the relationship is between 1 and 3, given the information that we have been given, okay? And so right off the bat, we can also say the relationship between 2 and 3 is that those are congruent, right? Angle 2 is congruent to angle 3. And we can say that because of what theory? The theory that we know this is true is they're on the same side of the transversal, both on the top. Those are corresponding angles. Corresponding angles, okay? So we're getting closer. Now we need to connect is angle 1 congruent to angle 3. And we're going to write that as a statement right now. And the reason why we know that is we can use substitution right here. We know 1 and 2 are the same, so we just plug in angle 1 in for this equation right here, and then we get angle 1 is congruent to angle 3 just by substitution. By substitution. And then that last statement then is we can say R is perpendicular to T, and the reason why we know that is because angle 1 and angle 3 are congruent. And remember in our theories, we said that if we have a linear pair that's congruent on both sides, then that means that those lines have to be perpendicular, okay? And they're supplementary. All right, I'm going to get you started on this practice problem. It says a carpenter's square forms a right angle, and this is my best little attempt at having a carpenter's square. Remember, a carpenter's square is just one of those, it forms a right angle is what it does. Okay, so a carpenter places the square on so that one side is parallel to an edge of the board. What that's saying is that pushes the square and it's on one edge of the board. I'm going to turn it this way. Okay, and then he draws a line along the other side of the square. Okay, so he puts it right up here and he draws a line on that square. Okay, now that would make perpendicular lines, wouldn't it? Yeah, make perpendicular lines. And then it says, then he slides the square to the right and draws a second line. And the question is, are the two lines he has drawn parallel? And explain. Good luck, hope you do well on it.